Hey everybody, this is Larry. This is day 15, maybe, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today I am in Buenos Aires, just walking around trying to get food and try to not get run over. I'll show you some clips and let's go. These are thick slices, but they're kind of on the small side. I guess my phone for comparison? I don't know. I don't know how I feel about it, but I'm still going to be happy, I hope. Hey everybody, this is Larry. This is day 15 of the, almost said October. Wow, time really flies. It's already November 15 of the, November Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Hope you enjoy my walking around footage here in Buenos Aires. Hopefully there's more to come as well. I'm just kind of getting warmed up. I'm really I had a red eye, and usually I sleep pretty okay on a red eye, but this time I don't know. I just wasn't able to. I think I kind of I don't know. It was very weird. So I've just been tired, and hopefully tonight, right after this video and after shower, I will go to bed. And tomorrow I'll be more refreshed and hit up the city, if you will. All right, but before that, let's take a look at today. Before that, let's take a look at today's problem. We have 32, 34. Count the number of substrings with dominant ones. Also, let me know if you're in Buenos Aires, obviously. So or if you have recommendations beyond. All right, let's go. We have a binary string S. Return the number of substrings with dominant ones. A string has dominant ones if the number of one in the string is greater than or equal to the square of the number of zeros in the string. Okay. I thought maybe I thought maybe it was going to be n squared, to be honest, but look at the constraints, that would be tight, so I guess not. Actually a little bit surprised, because I feel like we did this one recently, but with the prefix sum, I'm trying to, like, we did sorry, I'm taking an extra beat because I'm trying to think, because we did the Q4 from the contest last week, right? Let me give you a little bit of background. I mean, you might not know this because if you don't get into the contest, that's fine. And maybe spoiler alert, my fault. But what I was going to say is that from that, you could reuse that same idea, right? So that's why I'm like, if that's the case, then, well, no, it's not, because it's not one-to-one. It's greater than or equal to the square of the number of zeros. How would I think about this then? I mean, maybe it's not. No, I don't think so. I mean, I think, I don't think the same logic holds. Okay, then let's move forward a little bit. Then maybe there's another idea. Okay. Number of substrings, so the number of ones, obviously, that's fine. And then twos. 2. Can we do a sliding window on ones? Like do an n squared that way. Maybe? It'll be tight though. Greater than or equal to the square of the number of z. So why is this? Oh, these are non-dominant ones. They kind of do a Uno reversal on me, so I got confused. That's why I was like, what? It doesn't make sense, right? Okay, fine. I mean, I think there are two ways to think about it, right? One is they actually kind of gave you a little bit of a hint there, which is one way is to count this, or the other way is to count this, right? Do feel like I should be faster on stuff like this, to be frank, but okay. So 1 1. So let's say you have 1, then it's 1, right? Oh, I see. Okay. Okay, I see. Because the idea here then, right? I see. So you can iterate on the number of zeros. So wow, I mean, that's clever. I mean, that's cute. I guess it is kind of, yeah. Okay, let me step back a second and actually explain it. But I was still validating to myself because I wasn't quite sure about this one. But the idea here, the key trick, is knowing that if, okay, you say, okay, let's do a sliding window for n is equal, oh sorry, not n, z, let's just say for number of zeros is equal to 0, right? Then now we try it for 1. Try it for 2, try it for 3, ... right? And the thing that you may kind of get worried about is that, well, for this one, this may take O of n, this might take O of n, and so if you ... it, this will be O of n squared if you're not careful. But the thing is that because of this, this is actually kind of like a great intro to square root I mean, not quite, but that kind of idea, right? Is that it has to be greater than or equal to the number of zeros. That means that the only possible strings means that z has to be less than or equal to the square root side, right? Or n to the negative, or n to the half, right? And the reason being that if z is greater than that, there are not enough ones to go over it, right? I mean, you can say that, I mean, another way of writing it more mathematically might be that the number of ones, so 0 plus 1 is equal to n, right? And then O is greater than equal to 0 square, right? The number of zeros. So that means that O, the smallest case is going to be right? So Z, of course, is just, something like this, right? And you could and this is basically what we said, but maybe in slightly more visual form, more mathematically visual, right? And then as a result, then now what is the complexity here, right? Well, we're going to do a loop. This only loops to n to the half, square root of n. So that means that this is going to be n to the three halves, right? Or if you want to write it another way, it's going to be O of n times square root of n, right? And that's basically the idea, and from that, it should be easy to solve, right? Because we're just doing the O of n thing. I'm gonna go to the fridge and get a water. I don't know why I'm so thirsty. But yeah, that should be good. Oh, give me a water. All right. And that's it, right? So then now we just have to do sliding window. Now we do sliding window for z is equal to whatever, right? For all the cases. Maybe we'll even have a helper function, right? It's called count, say. It's like max max 0 or something, maybe. I don't know. Math is hard. Right, and then now we just do a sliding window, right? And basically the idea behind the sliding window, this is kind of hard for a medium, isn't it? Unless I'm doing it like a crazy way that's not intended. I don't know. But yeah, okay. So then the idea here is just sliding window, right? So we have total is equal to 0. We have for right in range of n. I guess we'll never define n. And then the idea here is, right? Actually, I mean, you can do it this way for sure. Oh, no, it's fine. I think it's fine. Right? Yeah. And then we just count the number of zeros, right? 0, 0. And now if s of right is equal to 0, then we increment 0. And then while 0 is greater than max 0, we, if s of left, sliding window stuff, right? And then now the substring that we have is going to be at most max 0, right? And then it is the longest string that we have ending in this current string that has max 0. That's not quite right. I mean, you can't do it that way. You have to do because if this is the max, then you don't count fully, right? You have to count. You have to count to the next 0. That's weird, right? I mean, we could pre-calculate it. It's not super hard, but it is way. I feel like the way that I'm doing it is a little bit wonky. You could also do. No, I think that's fine, but I don't know. I'm not a fan. Yeah. Basically, the idea here is, you just keep going, and then now this is the longest string that has actually, and this should not be max 0. This should be exactly 0. Otherwise, you double count stuff, because we want it to be exactly. Okay, fine, right? Should be, let's say, T0 for target 0, right? And now, if we're at the target 0, then now, if we're at the target 0, then that means that this is the longest string we have of exactly that target. And then, but this is the longest of that substring, right? So then now you can chop, so let me actually just visualize this way a little bit. But for example, let's just say the target 0 is equal to, say, 2, right? And then now you have like something like this, right? And then now when you slide, let's just say you were here, right? Let's just say you were here, then you slide, okay, you Gucci, you slide, you Gucci, you slide, you Gucci, you slide, and then now, because as a result of this slide, you now you have 3 zeros. So then now you have to move them one by one. You have to just move one, actually. But as I said, then now this is going to be the longest thing, right? So then now you just have to count the number of prefix ones here. And the number of prefix ones is the number of sub-arrays that you can have, right? Well, plus 1. And what I mean by that is that because, well, no. I mean, yes. But you also have to do the square thing. That's the other part that I forgot. For example, here, then now you do some math on like, okay, this is the smallest thing that you have to do, right? Because zeros are 2. Oh, I guess then that makes it easier actually, because then now we don't have to count we don't have to keep track of the next 0. It doesn't matter where the next 0 is, as long as because anything with these 2 zeros inside, everything outside, as long as okay, well, no, this is so annoying, because then now here you only count two ones, right, in this substring. And what I mean by 2 ones is that you count this, right? This is a valid substring, and then this is a valid substring with a 1 ahead of it. And then the one with the 1 ahead of it is also a valid substring. So you have 3 valid substring. The other way that you can think about it or the other thing that we were showing is that maybe you have something like this, right? But then here you need at least 4 of these, and this is a little bit easier because then now you can just chop it up at 4, and then when you chop it up at 4, then you could count the extra 2 very easily. But this is an edge case. I mean, this, I'm not going. I mean, I'm not. I think some of it is just like me trying to do a sanity check. Like, this isn't impossible for me. This isn't hard. I mean, I know how to do this. It's just a lot of what I call bookkeeping. It's just keeping track of where the next 0 is, etc., etc. But it just seems so like more annoying than it should be, and I feel like, and sometimes that's a symbol of me just getting it wrong, but also maybe I'm just wrong on that. So yeah. And the thing about this problem is that you can pre-calculate the next 0, right? Because, for example, if you're at this index, the next 0 will always be here. It doesn't change within the problem. So we can definitely just do it that way. But I was just like, there's so much work on this problem, right? That I feel like I'm overcomplicating things probably. Right, and we're just counting backwards so that we get the next 0, right? So actually, I think if we make it n, it actually is the math works out better that way. But yeah, if what's it called, s of I. But I think we want. I don't know if we ever used this actually, but I guess we always do this anyway. And then now we can check, right? So here we want so right minus left plus 1 is going to be the length, right? Of the substring, the longest substring that we care about, and then now we want to chop off okay, so then left, we want to say next 0 of left, next left of 0. How am I like driving myself nuts? Maybe. Okay, so then now you have something like this, right? Okay, so if the next 0 of left, so that is going to be the in. So then now right minus this plus 1 is the length of the 2 zeros. If this is greater than or equal to, you have the target 0 plus target 0, right? Because then now this is 0 and these are the number of 1s. If we have more numbers than that, and we know that T0 it's in this, so this is basically, you could say subtract T0 on this side, and then you say the number of 1s is equal to this. You could say it either way, right? So I'll write it out actually, fine, right? So within this substring, you could calculate that, and this is just within the next 0, not all of them, right? So here, 1s within, let's just say is equal to this minus T0, right? So if 1s within is greater than T0 times T0 because of a reset, about the square, is it equal to or greater than? Okay, equal greater than. If that's the case, then everything that goes outside of it, we can just count as optional, what I call degree of freedom, right? So then here, we can say total, we add, so yeah, let's just say within this is range. No, that's a thing. So let's just say R for range. So then now we have the range minus 1s within minus the number of target zeros, which we have exactly, and then that is the number of degree of freedom, right? Plus 1, right? Because here you can, yeah, you can see that with the 2 1s, the 3 choices, right? Okay. Otherwise, otherwise we fell short, or we're too short on the inside, which is fine, right? I always have to make sure that this is no, I was going to say I have to make sure that this is non-negative or not negative. But I think this, maybe I'm wrong, but I think this should be, because otherwise this cannot be true. But maybe I'm wrong on that one. I don't know, I'm so tired. This is an annoying problem. It's not even hard per se. But okay, I mean, actually it's kind of interesting. I'm just being annoyed. Not enough sleep. Okay, so then otherwise, then now we can just take the outside part, right? So we have t0 plus t0 times t0, right? So that's so we have the range minus this, because that's the number of characters, and then these are the number of characters left, and then this number plus 1 is the number of things that we can do. But now here, this one, we have to do a max of 0, so that we make sure that we have enough things. I think this is roughly right. But I think this is maybe also a little wrong. For the case of t0 0 to 0, maybe, because in that case we have something like this. Yeah, because it counts. Because if you have t0, if you have something like this, this would say, okay, you have 1, and then now for the next one it would do 1. Maybe that's fine. Maybe I don't know. Let's just run it. Right. Sorry, friends, I'm really tired. Yeah, and even I'm not going to submit this yet, right? So I'm just trying to print it out and see if this matches what we expect. And we're going to end, because I'm too lazy to go to square root of n, because I wanted to double check things real quick. Okay, so definitely 11 is the wrong answer for 1, right? Because we would just write like, even though in theory everything bigger than square root of n should give you nothing, right? That's why, you know. But 0 is definitely not right, right? Wow, 8. 8 is a lot for just 2 ones. I wonder if this is giving me ones for some reason. Give it a try. I mean, this is clearly something wrong, because left should not be greater than right. Right? Did I reuse left somewhere by accident? Why is left greater than right? 0. Oh, because... No, I mean... No, what? What? Alright, I mean, something is clearly wrong, because left is greater than right, which it should not be. Sorry, friends, I'm so tired, actually. This really do drain me. Okay, so it goes 0 0 with 1. I see. This should be afterwards, but I thought it would be before. I'm trying to think. Why did this? Why? Maybe we just don't handle zeros well. I don't know. But I don't think this is right even for 2s. Right? So it's not quite. Sorry, friends. I'm just like struggling today. It should not be hard. Maybe I'm missing something like really dumb and obvious for this one. So the target is 0. Okay. Where did I write test? Oh, I deleted it, that's why. I was like, why? Three is 2, which is definitely wrong. There's just not enough things to make it 2. Alright, 0, 1, 2, 3. There's only 1 numbers. But that means that this is never true, and then this, see, it's going to be R. Oh, it's going to be R, which is the range, which is 1 number. Right? Which is right? It should only have 1 number. The problem is that it's adding 2, which is why it got 2, right? Oh. Okay, total is 2, 1, 0, 0. Did I add twice or something? Why would it be the case? Do I shadow something by accident? Right? 2, 1, 0. So why did it get added? Was it already Oh, I have a +1. Of course I have a +1. Is +1 wrong? Maybe +1 is wrong. Okay, at least we fixed this. I mean, I don't know if it's right. 3, 3 giving 1 looks right. And then 3, 4 given 3 does not feel right. Right? Yeah, it doesn't feel right. Yeah, it's 0 and it just got lucky then, right? Because the number of zeros for 0 zeros should have 3, not 4, and it just canceled out. So definitely this is wrong. 3, 4 is 4. Why do I think 3, 4 is 4? Yeah. Why does this print twice? Is it supposed to print twice? Probably not, right? Oh, because I have this and then I print, I am dumb. Okay, fine. It's still wrong though, but at least it's not printing twice, which was confusing. Okay, so then now you have, so then the other one is still here. Is it? One's within. I'm just guessing that this is negative because this one is probably n or something, so then this ends up being negative, and then this is awkward, and then it does the math wrong maybe. No, I mean, oh wait, I'm looking at the wrong one. Still no. Oh wait, one's within is 0, which is true. But for 3, 4, there's 0 ones within. So then now R is 2 numbers. So it should only have 3. Is it the +1? Am I just really confused about the +1? Or maybe I +1 here and I got confused? Maybe. Okay. I mean, now I know it. I mean, of course, it should be wrong, right? It's correctly wrong because then now zeros have 3 cases, including, yeah, 2 that ends in 4, which is what this is saying. But now, the 1 case should have 2, right? Okay, so this is target 1. Zero, add you 0, range of 1. Makes sense so far. But then this thing is, so then this is -1. So then now it just adds 0, which is true. And it does that correctly. Left, right, 2, 3. So they're both 1s. That one adds a, no, this one's wrong then, because it should add a 1. Because then now, here, you have this. How many degree of freedom do you have? You have 1. You're missing a 1 somewhere. Why does it think? No, that's why I have a +1 here, I guess, earlier, right? Because if, yeah, because we have 1 length, because those are all considered, and then, yeah, so this should have a +1, but that would make it break the other piece, so maybe one more. I'm thinking, I mean, I can figure this out. I feel like I'm doing this in a dumb way that I didn't do last time or something, because this is too frustrating. So I'm trying to reset my brain a little bit and try to think, is there any other way of doing it with this idea of sliding window and on the zeros? And welcome to Argentina. I mean, I don't want to keep on going back and forth on the 1s and zeros, and that's why 0, 4. I mean, it's back here again where 3, 4. 3, 4. We have 2 degree of freedom, so I guess actually this is right, but the 3, 3 having 2 is probably the wrong one. I see. That doesn't make sense though, actually. Because if these are all zeros, then R should just be 1. And that's why this is fine. But then the other case was we have 1 range left, right? Okay, so this works for... man, what is wrong with me? But if target 0 is 1, then you have something like this, then why is that different? I'm trying to think about a 0 and 1 target 0 case. And why is one undercounting and the other is not? Oh, because you cannot have empty string. Yeah, because you cannot have empty string. So, okay, so we do want to do a +1. And I think what I'm going to do is just special case T0. So if T0 is equal to 0, then now we just count the number of ones, right? Well, then you have to do the chunk streak thing, right? Fine. So then for C in what's it called? S. If C is equal to something like this. Okay, so this now overcounts. I don't know if this, I mean, no, this should see, I mean, we have a special case that should specifically count. Why does this overcount? 2 to 4. We think there are 2 answers. Why do we think there are 2 answers? Why do you think there are 2 answers? 1, 2, 3, 4. No, this is right. But you can extend to the left. All right, so we have 1. Oh, I see. Because this 1, there should be the 1 within its case then. Maybe I just didn't do that one right anymore. That doesn't make sense. Okay, it doesn't even go inside, so that doesn't even make sense that I'm looking at it. But okay, 2, 4. The reason why it thinks there are 2 is because the required is 2, but this 0 actually, I thought it would go in this case actually. the 2 ones within, so oh, because this is n and left is at a 0, but okay, so this is wrong then. And how I did this? Should have done it the other way. I'm wrong again. Okay, so then now it does the inside calculation more. And maybe we're off by 1. That's just like, I'm not confident about that. 2, 3 is 1. 2, 4 is 2. I mean, that's kind of right. Wait, is 2, 4, 2? Oh, no, it's 1. I see. Yeah, that's kind of right. But this one, now I have no idea. Which ones am I missing? Did I remove? This is a medium. What am I doing wrong? I'm so frustrated with myself because I'm so tired. I was going to just hopefully go to bed, but let's look. One, okay, that seems right so far. 3, that means the 2 choices. Also true is 1 and then 2. This is 5 or 2 more. I guess that's true. It's gonna be 1, 2, right? So that's 5. That sounds okay. And then now next it's gonna be 2 and 2, 5. Two being 1 is right, I think, because there's only one example, right? And it requires an entire string, so it has to be that. But 2, 5, right? 2, 5, right? That's 8. But there's 3, so it's gonna be 0, 1, 2, 3. That's 13. How am I getting 6? I mean, what am I missing? Which ones am I missing? Which one am I missing? I mean, the length 0 ones are right. And then, let's see. 1, 2, 3, 4. 5, right? What am I missing? I don't know why there's so much. Was it empty strings? But that doesn't make sense. The empty string, they wouldn't be here. Oh, whoops. I'm just dumb. Okay, so for things that contain 1, 0, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm definitely undercounting. Why am I undercounting? I have 1, 0. Okay, that's 1. That's 2. Is this plus this? We have this plus this. Oh. Huh. When I have this. No, when I have this. Do I not handle this case? 2, 5. So 0, 3, 0, 1, 2, 3. We go here. And then now it should be just here, right? But we don't add anything from 2 to 4. We should have a 2 to 4. Why does it jump to the 5? Because of, is it because of here? Or something even dumber. So we want to see 2, 4. Why does it go from 0, 3 to 2, 5? Well, it's because of this. Because we have to add first. Alright, that's why I wrote this way before, but I think I just confused myself a lot. Clearly. Alright, let YOLO submit. Yeah, I printed out stuff, so I left out a thing. Maybe that'll punish me. I'm so tired, my eyes are closing on this stuff. Really would love to sleep. Oh, and I forgot to take this out. So I'm just very sloppy. Yeah, I mean, that's not surprising because we just forgot a bunch of things. And as we said, we're going to take the, square root of this. We could do, yeah. Just very sloppy today, friends. Sorry. I think the idea is right. I mean, we're very close on ideas, but I think the zero cases, I was trying to make the zero case work longer than I should have, perhaps, instead of special casing it. And yeah, I mean, this is very slow, but I think the idea we were right about, but I'm just too tired. Yeah. This is a square n loop, right? And this is an O of n loop. So this is going to be square root of O of n times square root of n. And that's it. That's what I have for this one. Wow. I mean, I guess it was hard last time. For some reason, saying that this is a medium, I thought that it would be much easier. But as you can see, I did crazy things last time. It is a little bit faster than today. But you can see that, yeah, what did I do? I converted to Java. So, okay, so I don't blame so bad. Oh, I mean, this is basically what I did today. Okay. I mean, I don't know how long I took that time, but it seems like there was no easy way. Oh, yeah, so instead of pre-processing, I binary search, I would guess, to get to Z. Oh, no, I just actually... No, I mean, I don't know. This is a crazy man's problem. I don't know. But let's see what the hints give you. I see. I guess that is the same idea. But it's basically the idea. I mean, it's kind of the same idea, but basically for each thing, we just go loop zero, all the zeros back, or square root of n zeros back. I don't know. Let me just show you my code. I'm going to call it a night. Thanks for watching. Here's the top. Here's the count function, including special casing for 0. Did I special case 0 last time? Actually, let me just show you finish. And this is the final loop. What did I do last time? That time I didn't special case the 0 case. So I don't know. Yeah. Anyway, I don't know. This was way harder than I expected, to be honest. And I guess last time I probably thought the same thing, so I don't know. Anyway, thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.